In the last couple of years, the DNS-based content blockers have become quite popular. Since its inception, the Pi-hole has been the main player in this arena, thanks to its tiny hardware requirements and a beginner-friendly UI. Pi-hole is a great project and it serves its purpose well, but I believe it is in man's nature to always be out looking for something better. When Pi-hole was first developed, the DNS encryption wasn't a thing, but in the last couple of years, the DNS encryption have really taken off, with every major operating system now supporting it in 2022 in one form or another. Sadly, Pi-hole has been left behind in this regard because neither it offers DNS over HTTPS nor DNS over TLS. To accomplish DNS encryption, you have to rely on third-party packages in Pi-hole. Another major feature where Pi-hole has been left behind is providing a native support for some sort of DNS prefetch. Pi-hole does offer a regular DNS caching mechanism, but with prefetch, the program can automatically update your DNS cache in the background, so your local DNS cache stays as fresh as it can get. However, the Pi-hole case isn't all that wintry, as would it become clear ahead in the video. The project has its merits as well. For now, let's look at AdguardHome. Compared to Pi-hole, AdguardHome is relatively a new project, okay, and I believe it has not reached that level of recognition even in the tech space, where just about everyone can recall a product in just a blink of an eye. I believe there would still be many Pi-hole users out there who would not have even heard about AdguardHome, let alone try it. AdguardHome is also an open source project hosted at GitHub, and in my opinion it is very community driven. The AdguardHome users ask feature to be included in the project, and the developers of the project are interested ASAP to work on that feature in the AdguardHome. Thanks to its rapid development, a new beta version of AdguardHome is released every few weeks or so. Compared to Pi-hole, AdguardHome offers a native support for DNS encryption, and from the DNS prefetching side, AdguardHome does not offer a fully fledged DNS prefetching, but something called optimistic DNS, where the expired DNS cache is answered to the client with the TTL of 1 second. If the requesting clients are able to connect to the server, that's fine. AdGuard would update its DNS cache in the background. If they are not able to do so, the clients can again request the AdguardHome for DNS resolution and fetch the latest DNS records. Another advantageous thing about the AdguardHome is that its binary is self-contained. On a freshly created virtual machine based on Debian, it does not require any additional dependencies to get started. Just download the archive from the project's GitHub page, extract it, and execute it. On Pi-hole side, Pi-hole needs around 15 additional dependencies to run on a new Debian VM. However, the Pi-hole does initially consumes around 30 megabytes of additional disk space on a x64 virtual machine, which is around 6 MB lighter than the AdguardHome. And if you would not be running any sort of DNS encryption alongside Pi-hole, then we have a clear winner here. Otherwise, the ball can tilt in AdguardHome's favor, because popular tools like Cloudflare D for DNS over HTTPS requires additional 14 MB of disk space, and for dot you need unbound, which is around 5 additional megabytes. Pi-hole also consumes a less RAM with a DNS filtration list which features more than 1 million unique domain names. Pi-hole consumes around 30.3 megabytes of RAM, while AdguardHome consumes nearly 4 times as much memory at 113.6 megabytes of RAM usage. The disk space and RAM usage does not matter much if you are using a device like Raspberry Pi, but if you are running your setup on a device like a consumer router, you know that every megabyte counts. Lastly, I can think that only a niche would be utilizing this feature right now, but if one day you would be running your DNS filtration setup in the cloud, you really going to need this feature, and that is accepting encrypted DNS queries from your clients. Compared to Pi-hole, AdguardHome has the capability to run as an encrypted DNS resolver. So technically what you can do is put AdguardHome on your cloud service provider, provide it with a valid TLS certificate, and run DNS over HTTPS behind a random string, and voila, you have your own cloud hosted DNS resolver. Now let's bring the newest contender in the DNS filtration arena. What if you could have what AdguardHome have in tiny resources requirement, and within those tiny resources requirement have a proper support for DNS Prefetch. Well, let me introduce you to Blocky. Blocky is also an open source project like AdguardHome. It had its first release no more than 2 years ago in Jan 2020. The program consumes only 18 megabytes of disk space on x64 environment, which is lower than both the Pi-holes and AdguardHome's disk usage. It also does not require any additional dependency to run on a new Debian VM, and like AdguardHome, it also offers a native support for DNS over TLS and DNS over HTTPS. And yes, it can also work as an encrypted DNS resolver, so you can run it in the cloud just fine. Blocky also features a customizable DNS Prefetch feature. You can customize DNS Prefetch track window. You can customize how many times you have to visit that domain in that track window, so that Blocky would include it in its domain prefetch list. For the RAM usage side, with the same block list that features million plus domain names, Blocky came at the second place at 61.9 megabytes of RAM consumption. However, there's a point to be made regarding the Blocky's memory consumption. When the Blocky has downloaded and passed all the filtration lists, its RAM consumption is indeed lower than AdguardHome's. However, Blocky can have a problem parsing large block list on devices with low RAM. I'm not saying the devices like Pi 0 could have problems, but devices like routers can. Because of how Blocky currently works, it needs more than double RAM space when downloading and updating the blacklist. And when you have lists that have hundreds of thousands of domains per list, it can result in a device crashing. During my run, Blocky crashed my router 2 times by exhausting it all of its available memory, once when downloading the blacklist, another time when updating it. There is already an open issue on the project's GitHub page, and the developer of Blocky has proposed a solution for this issue. Let's just hope that the solution would be sufficient to fix the problem, but for right now, the Blocky has this problem and I am sharing it with you. There's one more point to be made here, and that is Blocky does not offer any web interface to configure its settings. For stats monitoring, it does offer a Grafana dashboard which works fine, but there is no web interface for program interaction. This is by design, I believe. The program is configured through a config file. The config file is hierarchy based, and I won't lie, it can be bit confusing if you are just starting out. Thankfully, getting familiar to it isn't that hard, so you won't be spending much time just to get the program up and running. Let's say, just for example, if you want to rewrite DNS queries to point to your custom IP address, the first 2 programs can do it from their web interfaces, but with Blocky you might have to tinker with its config file once or twice to get what you want, but you will be able to achieve it. It's not going to be that hard. All in all, Blocky can offer whatever AdguardHome can offer with lower disk space and RAM usage. Okay, now let's come to the DNS benchmark of these 3 programs. For this, I loaded these 3 projects with 33 additional blacklists. The new RAM consumption is as follows: 75.5 MB for Blocky, 146.7 MB for AdguardHome, and 33.8 MB for Pi-hole. Pi-hole indeed scaled exceedingly well with this rise. For benchmarking, I use this small utility called Naminator, and I ran the test 5 times with the same upstream resolver and queried the Alexa's top 100 domains. The results are as following. Blocky took the crown with the sum average of 54.49 milliseconds for the average DNS resolution time, 290.2 microseconds for the minimum DNS resolution, and finally the longest it took was 1.24 seconds to resolve the DNS query. On the second place came the AdguardHome with the sum average of 179 milliseconds for the average DNS resolution, 310.58 microseconds for the minimum DNS resolution, and finally the longest it took 1.24 seconds to resolve the DNS query, which is as same as the Blocky. At the last place was the Pi-hole with the sum average of 221.45 milliseconds for the average DNS resolution, 386.96 microseconds for the minimum DNS resolution, and finally the longest it took to resolve the DNS query was 1.94 seconds. The results are somewhat obvious in my opinion. Blocky, which runs entirely in the RAM, took the crown here. AdguardHome, which perhaps takes the middle ground between the RAM and the disk usage, came second, and Pi-hole, which is the lightest on the RAM, came third. So with prejudice, my conclusion is here as follows. If you have a device with extremely low resources to spare, Pi-hole is the answer. You won't be disappointed. It's a great piece of software. However, if you want a pretty web interface with direct program interaction, AdguardHome is a product for you. Also a great piece of software. Its developers have great ambitions for the project. I won't be surprised if one day the AdguardHome surpass the popularity of the Pi-hole. Finally, Blocky, if you have a RAM to spare and can get around using a config file or setting up a Grafana dashboard. If you want your DNS resolution to get as snappy as it can get, you know what you have to use. Okay, I believe for improvement, Blocky can introduce a simple config generator to get the users started on using Blocky. Otherwise, Blocky is on a fantastic trajectory, and I can hope the best for the future. Okay, my dear people, so this was it for this video. So I have the hopes to see you in the next video. Bye everyone.